Okay, let's talk about something that gives a ton of calculus students a headache. Integrals with those really messy, complicated-looking roots. They can just stop you dead in your tracks. But what if I told you there's a way to literally make them disappear? Well, in this explainer, we're going to break down a technique that turns these scary problems into something way, way simpler.
Does this look familiar? You're just staring at an integral, it's got a square root, maybe a cube root in there, and none of your usual tricks are working. It is such a frustrating spot to be in, but trust me, you are definitely not the only one.
But the good news is there is a super elegant technique designed for this exact situation. It's called rationalizing substitution. And honestly, it is the key that's going to unlock these difficult integrals for you. So what is this thing exactly? Well, rationalizing substitution is this really clever method where our entire goal, our whole mission, is to get rid of the radical, that pesky root. And we do it by inventing a new variable, we'll call it u, and just setting it equal to that entire messy root. This one simple move completely changes the game. You know, you can think of it like we're changing the language of the problem. We're translating it from this scary, complicated sentence written in x with roots all over the place to a friendly, simple polynomial written in u. And that's a problem we already know how to solve. All right, here's the four-step game plan. It's pretty straightforward. First, you're going to set u equal to the entire root. Second, you just rearrange that little equation to solve for x. Third, you figure out what dx equals in this new u world. And finally, this is the magic moment. You plug all these new pieces back into the original integral, and poof, that radical just vanishes. It's awesome. Okay, theory is great and all, but let's actually see this thing in action. We're going to start with a pretty straightforward example, just to get a feel for the process and, build up a little confidence. So here's our first patient, the integral of x times the square root of x plus 1. You see that square root? That's the part that makes this whole thing tricky. So let's unleash our new technique on it. Let's walk through this one together. Step 1, we make our substitution. We let u equal that whole root, so u equals the square root of x plus 1. Now if you square both sides, you get u squared equals x plus 1. Easy enough. Step 2, find the other pieces. From that last equation, we can see that x must be u squared minus 1. Then we find dx by taking the derivative, and that works out to 2u du. Now for the fun part, we substitute everything back in. The x becomes u squared minus 1, the root just becomes u, and dx is now 2u du. And would you look at that, the root is completely gone. We're just left with a basic polynomial we can integrate using the power rule. The very last step, and don't forget this, is to substitute back, replacing u with the square root of x plus 1 to get our final answer. Okay, that was a fantastic start. Now let's level up a bit. What happens when that root is hiding in the denominator and our substitution gives us something a little trickier to work with? All right, our next challenge is the integral of 1 over the quantity 1 plus the square root of x. Now the process is going to start exactly the same way, but this time where it leads us is a super common situation that you've got to be ready for. And this brings us to an absolutely crucial point. Sometimes after you substitute, you're going to end up with a fraction where the power of u on top is the same as or even higher than the power on the bottom. When that happens, you have to, must, use polynomial long division before you even think about integrating. It's one of those classic algebra skills that suddenly becomes a total lifesaver right here. So let's follow the steps. We'll set u equals root x. After we substitute everything, our integral becomes the integral of 2u over 1 plus u. Now notice, the degree of u is 1 on top and 1 on the bottom. That's our big flashing sign to do long division. When we do that, it breaks our one tricky fraction into two much simpler pieces, and these we can integrate directly. After that, it's just a matter of back substituting, and we've got our final answer. All right, you ready for the final boss? This is where this technique really shows off. What in the world do you do when an integral has not one, but two different kinds of roots in it? Before you even see the problem, I'm going to tell you the secret weapon. It's the number 6. Now, where does that come from? Well, if we have a square root, that's an index of 2, and a cube root, an index of 3, we find their least common multiple, or LCM. And the LCM of 2 and 3 is 6. This is the absolute key to making a substitution that will magically cancel both roots at the exact same time. And here it is. The integral of 1 over the cubed root of x plus the square root of x. I know, this thing looks intimidating, but with our little LCM trick, it's totally manageable. The whole secret here is our substitution. We let u equal x to the power of 1/6 using our magic number. Now just watch what happens. The square root of x becomes u cubed. The cube root of x becomes u squared. In one single move, bam, both roots are gone. They're just replaced by simple powers of u. And the rest of the process should look pretty familiar by now. The integral simplifies, and hey, we see again that the degree on top is higher, so we use our old friend polynomial division, integrate the result, and back substitute to get that final answer.
And there you have it. You've just added an incredibly powerful new weapon to your integration arsenal. This isn't just a gimmick for one specific problem. It is a whole strategy for simplifying an entire class of integrals that really stumps a lot of students. So let's just recap that core strategy one more time. If you see one messy root, let u equal that entire root. If you see multiple different roots, use that LCM trick for your exponents. Your goal is always to transform the problem into a simpler polynomial or rational function. Be ready to bust out your algebra skills like long division, and please, always remember to substitute back at the very end to get your answer in terms of the original variable x. You know, at the end of the day, this whole technique really shows the power of changing your perspective. By swapping out our variables, we took a problem that looked nearly impossible and turned it into something we could actually solve. It kind of makes you wonder, right? What other scary problems, maybe even ones outside of a math class, could be made a whole lot simpler just by looking at them from a new angle?